Okay, so imagine this. You can train for some of the most complex naval operations, and you never even have to leave land.
And get this, while doing that,
Yeah.
you can experience these incredibly realistic electromagnetic
It
conditions.
sounds pretty wild, right?
That's exactly what this project called META aims to achieve.
Meta.
Yeah, it stands for Maritime Environment for Training and Analysis.
Okay, so that's what we're diving into today.
We've got excerpts from a proposal that outlines the problem, a potential solution, and a whole lot of really interesting tech.
And it's fascinating because it seems like they're tackling something that's often missing in a lot of training simulations.
Yeah.
Like a realistic electromagnetic environment.
You know, it's kind of like if you were practicing for a football game,
Right.
but you didn't even think about the wind or maybe the other team's plays.
Yeah. You
I really need to factor in
factored all
all
out.
of the elements to really get that good preparation.
And when it comes to naval operations, that electromagnetic spectrum is so vital.
Yeah, it's how ships communicate, how they use radar to spot threats, and even how they engage in electronic warfare.
So we've got these excerpts, and they're from a technical document
Okay.
from a company called Terasynth.
I've heard of them.
And they're really claiming that Meta can simulate all of that with just incredible accuracy.
That's a bold claim.
It is. So
Yeah.
let's start with the problem. What are they actually trying to solve here?
Well, traditional training methods, or what they call LVC, which is live, virtual, and constructive training environments,
Okay.
often fall short when it comes to accurately representing that electromagnetic environment.
So it's like they're missing a key piece of the puzzle.
Exactly. Trainees might be going through these simulations and thinking they're prepared, but then they get out into the field,
Right.
and they're totally surprised by how complex things really are.
So Meta is stepping in to try and fill that gap.
It seems that way.
They're proposing a software platform that can generate these really specific electromagnetic signatures
Okay.
for different things at sea that emit signals.
So, like, what would
It's everything.
Give me an example.
From radar pulses to radio signals and even interference, all designed to mimic what you'd actually find out there.
It's like they're building a virtual world that replicates the electromagnetic landscape.
Yeah, and they're integrating all of this with EarthCloned, which is this incredibly detailed 3D environment.
Earth cloned. Yeah. I've heard of that too. It's supposed to be amazing.
So it's like they're not just simulating the signals, they're simulating the entire world that those signals exist in.
That's really interesting.
It is, I'm looking at the proposal here, and it looks like they break Meta's architecture into three main parts.
Okay, what are they?
So you've got the EMS simulation engine, which is kind of like the brains of the whole operation.
The brains. Okay.
Then there's the scenario management module, which is where you can create custom training exercises.
Right, so you can tailor it to specific needs.
Exactly. And then the last one is the visualization and integration module, which brings it all to life.
It sounds pretty ambitious.
It is a pretty ambitious setup.
Yeah.
But how do they achieve this realism?
Well, they're combining what they call deterministic models, which
Oh.
are basically based on predictable physics,
Uh-huh.
with stochastic models, which introduce randomness and variability.
So it's not just a set script. It can actually adapt and change.
Exactly like trying to predict which way a leaf will blow in the wind.
So it's like having X-ray vision for the electromagnetic world.
That's a good way to put it, and that's one of the things that makes this so interesting.
It's a pretty unique approach.
Yeah, this level of realism, the visual detail of Earth cloned combined with the advanced simulation, it's not something you see every day.
And they also talk about open architecture, which is designed to work with the Navy's existing systems like NGTS, AFSIM, and ITES.
So it's not a standalone system. It's meant to plug into what they already have.
Right, and that seems like a big focus for them, making it easy to integrate.
It makes sense. Trying to introduce a whole new system can be a logistical nightmare.
For sure. And then they highlight another advantage. Meta is supposed to be dynamic and adaptive.
Okay, so it's not just a static environment.
The electromagnetic environment is always changing based on things like the weather, the sea state, even the behavior of other ships.
So they're trying to capture all of that.
They are.
That makes a lot of sense. You don't want trainees to just memorize procedures.
Right.
They need to be able to adapt on the fly.
They've also designed it to be accessible and scalable.
So it's practical.
It can run on standard workstations and use cloud computing when needed.
That's smart. You can have the most amazing technology, but if it's not user-friendly or scalable.
It's not going to be very useful.
Exactly.
Okay, so moving on to their implementation plan.
Right.
They've laid out a phased approach over 36 months
36 months.
with the goal of having a prototype ready for real-world testing.
That's a pretty aggressive timeline.
It does seem like it,
Right.
but they've got a clear roadmap.
Right.
They've also highlighted some of the key people involved, like Ali Maven, the principal investigator.
His background is in AI, right?
Yeah, and then there's William Taubenheim, the technical lead.
And he's got that Earth-cloned experience.
Yeah. Right, so it seems like a good team, but they do acknowledge some potential risks.
Like what?
Well, things like the complexity of integrating with those existing systems
Right, because that could be a huge hurdle.
and just the performance demands of the system.
Yeah, making sure it can handle all of that data.
And even just getting the data they need.
So data availability is a concern.
It is, but they do seem to be trying to anticipate and address these issues.
Like they're really trying to think ahead.
Yeah, they're not just throwing technology at the problem.
They're actually considering all the angles.
So we've got the problem, the solution, the tech behind it all.
We've laid the groundwork.
But before we get too excited, let's dig a little deeper into what Meta is actually claiming to offer.
What are the specific advantages they're highlighting?
We'll get into that right after the break.
All right, so we talked about some of the advantages that Terasynth is claiming for Meta.
Yeah, like unprecedented realism, open architecture being dynamic and adaptive.
All that stuff.
But what does it all actually mean?
Yeah, how is this going to change things?
Right, what are the practical implications of this technology?
Well, the most obvious impact is on naval training itself.
Yeah, right.
I mean, the proposal really emphasizes how Meta could completely change the way the Navy prepares its people for those electromagnetic environments.
So instead of just like memorizing procedures.
It could be more about developing a deeper understanding.
Right, like how to make decisions in an environment that's constantly changing.
Exactly. Imagine a training scenario where a sailor has to navigate a strait
Okay.
that's filled with all sorts of enemy signals, radar communications.
And using Meta, they can actually experience the consequences of their choices.
Right. They can see how their decisions impact the electromagnetic environment.
So it's not just theoretical anymore, it's practical.
And they can adapt their tactics on the fly, see what works and what doesn't.
Learn from their mistakes in a safe environment.
Exactly.
So it's really about creating a more realistic and engaging learning experience.
Yeah, where sailors can hone those critical thinking skills.
And that kind of shift in thinking. I mean, it could have ripple effects throughout the whole Navy.
Yeah, it's not just about training individuals.
It's about creating a more agile and adaptable force as a whole.
Right.
But let's not limit ourselves to just training.
No, I think this kind of technology could be applied to other areas of naval operations, too.
Yeah, I was just thinking about that. What about operational planning and analysis?
Absolutely. Instead of relying on these theoretical models, commanders could use Meta to run simulations.
Right. Test out different mission scenarios.
Yeah, explore different approaches.
See how those approaches would play out in a realistic electromagnetic environment.
Exactly. And because Meta is so dynamic, those simulations could include all sorts of factors.
Things like real-time intelligence weather conditions, even the behavior of enemy forces.
It's like a virtual war room.
Yeah, where you can play out different scenarios without any real-world risks.
So we've got training, we've got operational planning. What else?
What about research and development?
Oh, yeah, that's a good one.
I mean, Meta could be a really powerful tool for testing new technologies.
Right. You could test a new electronic warfare system or a stealth communication protocol.
In a safe virtual environment before you even think about deploying it on a real ship.
Exactly. You can gather data, see what works, what doesn't.
So it's like a virtual proving ground for all these new naval capabilities.
I like that a virtual proving ground, it captures the idea perfectly.
So we've got training, operational planning, research and development.
It's a lot.
It seems like Meta is much more than just a training tool.
Yeah, it's a versatile platform with a wide range of potential applications.
But let's not get too carried away. I mean, Meta is still just a proposal.
Right. It's a concept at this point.
There's still a lot of work to be done.
Yeah, and a lot of challenges to overcome.
It's like we've drawn up the blueprints for this amazing new building, but we haven't even started construction.
Exactly.
We've talked about the benefits, but what about the drawbacks?
Yeah. Are there any concerns or criticisms that we should be thinking about?
There are always potential downsides to consider.
Like, what are some of the things that people might be worried about?
Well, one concern that always comes up with AI is the possibility of bias.
Right. Those AI systems are only as good as the data they're trained on.
And the algorithms they use.
Exactly. So if the data is incomplete or biased,
or if the algorithms themselves reflect some kind of unconscious bias,
then the simulation could end up giving you misleading results.
It's like training a self-driving car using only data from California highways.
Yeah, and then you take it to the East Coast in the winter and it's totally unprepared.
So we need to be very careful about the data that's used to train Meta.
Absolutely. We need to make sure it's diverse, representative, and as unbiased as possible.
And we need to be transparent about the limitations of the simulation.
Yeah, let people know that it's not a perfect reflection of reality.
Another potential concern is something called escalation of conflict.
Escalation of conflict. Okay, that's an interesting one.
The idea is that if it becomes too easy to simulate military operations, it might make countries more likely to actually use force.
So it's like saying that because nuclear weapons are so destructive,
Right.
they actually act as a deterrent.
Yeah, because no one wants to face the consequences.
Exactly. And if planning and executing military actions becomes too easy,
Could that make conflict more likely?
that's a tough question. I don't think there's an easy answer.
No, but it's definitely something we need to think carefully about.
Right, as we develop and deploy these
We
technologies.
need to make sure they're used responsibly and ethically.
Absolutely. Human judgment and ethics need to be central to any military decision.
And I imagine some people might also be concerned about the impact on human expertise.
Yeah, what's the classic fear?
The robots are taking over.
Exactly. And while Meta isn't designed to replace human operators,
We do need to think about how its use might affect the development of human skills.
right, how do we make sure that people are still learning and growing?
It's about finding the right balance
Yeah, between leveraging the power of AI.
and preserving the value of human judgment, experience, intuition.
All those things that make us human.
It seems like we've covered a lot of ground in this part of our deep dive.
We've talked about the potential impact of Meta on training.
We've explored some broader applications.
And even delved into some of those ethical considerations.
There's a lot to think about.
These are big questions about the future of warfare, the role of technology, the choices we make as AI becomes more integrated into our lives.
And in the next part, we're going to take a closer look at the specific claims being made in the Meta proposal.
Okay, so we're going to get into the details.
Yeah, we'll examine how valid those claims are and explore some of the potential challenges and opportunities that lie ahead.
I'm looking forward to it.
Okay, so we've talked about the big picture, the potential impacts, the ethical considerations.
Yeah.
But now let's get into the details of what Terasynth is actually proposing.
Let's see if their claims hold up under closer scrutiny.
Right. One of the boldest claims they make is unprecedented realism when it comes to simulating that maritime electromagnetic environment.
Yeah, they're not just talking about incremental improvements here.
Right. It's like they're saying this is a game changer.
And a big part of that claim rests on the integration of EarthCloned and that sophisticated EMS simulation engine they've developed.
So let's start with EarthCloned. What makes it so special?
Well, it uses vast amounts of geospatial data, satellite imagery, terrain models, even 3D building data,
Wow.
to create this incredibly realistic virtual replica of the Earth.
So they're not just simulating the electromagnetic environment, they're
Yeah.
actually simulating the physical world that those signals exist in.
Precisely. And that's crucial because the physical environment really influences how electromagnetic waves behave.
Yeah, I can see that.
You know, signals can be reflected, refracted, absorbed by different surfaces.
Mm-hmm.
And all of those interactions can have a huge impact on things like radar communications, electronic warfare.
So by accurately modeling the physical world, Meta can simulate those interactions with a level of realism that wasn't possible before.
That's the idea, but EarthClone is only part of the equation.
Right.
The other key element is the EMS simulation engine itself. This is where the real magic happens.
Okay, so how do they achieve that level of fidelity?
They're using a combination of what are called deterministic and stochastic models.
Okay, break that down for me.
So deterministic models are based on the predictable physics of wave propagation.
Okay.
But stochastic models introduce elements of randomness and variability.
So they're acknowledging that the real world is messy and unpredictable.
Right, and they're building that unpredictability into their simulation.
Interesting. How do they actually do that?
Well, they talk about using ray tracing techniques to simulate how signals travel through the environment,
Okay.
taking into account things like reflection, refraction, diffraction.
Yeah.
And they're also using statistical models to represent all those little variations that happen in the real world, like noise jamming atmospheric effects.
So it's a lot more than just a simplified model of how these signals work.
It's a much more nuanced approach.
But the question is, can they actually deliver on that promise of unprecedented realism?
That's the million-dollar question, isn't it?
It is. It's a bold claim.
And it's going to require some pretty rigorous testing and validation.
So they can't just say it. They have to prove it.
They have to show that Meta can actually accurately reproduce what happens in the real world.
And that those simulations are consistent and reliable.
And they need to be transparent about their methods so independent experts can scrutinize everything.
It's like any scientific claim, you need to be able to back it up with solid evidence.
Absolutely.
Okay, so let's move on to another key claim, the open architecture of Meta.
Right. They're saying it's designed to be compatible with the Navy's existing systems and standards.
Which seems pretty important.
It's essential. The Navy has invested a lot in their current infrastructure.
Yeah, it wouldn't make sense to rip and replace everything.
No, not at all. Meta has to be able to play nicely with what's already there.
Share data, communicate, effectively integrate seamlessly.
It's like trying to switch from iPhones to Androids overnight.
Not going to happen.
Not a chance.
So how do they plan to achieve this level of integration?
Well, they talk about adhering to industry standards,
Okay.
using open communication protocols, and they even mention developing custom adapters if necessary.
So they're acknowledging that there might be some bumps in the road.
They're not being naive about it.
They also emphasize the modular design of Meta, which means it can be configured and customized for different needs.
That flexibility is going to be key.
It seems like it.
But ultimately, the proof is in the pudding.
They're going to have to show that it actually works in practice.
Right. No system is perfect.
But they need to demonstrate that Meta can actually integrate with those existing systems without causing disruptions or security issues.
Integration is one of those things that can sound great in theory.
But then in reality, it turns out to be much more complicated.
That's right.
Okay, another claim they make is the dynamic and adaptive nature of Meta.
Yeah. This is where it really starts to get interesting.
They're saying that it goes beyond those static scenarios and incorporates things like changing weather conditions, unpredictable emitter behavior, and even the actions of the trainees themselves.
It's a big step forward from those traditional training simulations.
Right, which often feel very scripted and limited.
Exactly. It's like the difference between playing a video game on easy mode
Right, where you always win,
and playing on a harder setting.
where you have to think on your feet and adapt to unexpected challenges.
That's the kind of experience they're trying to create with Meta.
So by forcing trainees to adapt their strategies, Meta can help them develop those critical thinking skills they'll need in real-world operations.
They talk about being able to incorporate things like dynamic weather conditions, rain fog, rough seas.
Stuff that can really impact how those signals behave.
If exactly. They also mention simulating things like random jamming signals, unusual radar patterns.
So they're throwing in some curveballs.
Trying to keep the trainees on their toes.
But creating that kind of dynamic environment comes with its own challenges.
Right, it does. You need to make sure the simulation stays realistic and believable.
Right, it can't just devolve into chaos.
Exactly.
And they need to find that sweet spot between challenging the trainees and making the simulation feel unfair or frustrating.
It's a delicate balance.
Okay, so let's move on to their implementation plan.
All right, how do they actually plan to bring this to life?
They've outlined a phased approach over 36 months with specific milestones along the way.
So they've broken it down into manageable steps.
Yeah, phase 1 is all about developing those core components, the simulation engine, integrating it with Earth-cloned, building the scenario management module.
So laying the foundation.
And then phase 2 is focused on refinement and integration, expanding the sensor database, adding more advanced visualization tools, and starting to integrate with those existing Navy systems.
So building on that foundation.
Exactly. And then phase 3 is all about testing validation and making improvements based on feedback from users.
It seems like a pretty thorough plan.
It does. But like any large-scale project, there are always potential risks.
What are some of the things they highlight as potential roadblocks?
One of the big ones is integration challenges, making sure Meta works smoothly with the Navy's existing systems.
We talked about that before.
Right? It's critical, but it's also really complex.
Different systems can use different data formats, different communication protocols, different security standards.
It's not as simple as just plugging a cable in.
Not at all. And even if they solve the technical challenges, there's the human element.
Right.
Getting different teams to buy into a new system to change the way they work.
That can be the big challenge.
It's one of those things that's easy to overlook, but it can make or break a project.
Another risk they mention is performance bottlenecks.
Ah, yeah.
I mean, simulating those complex electromagnetic environments requires a lot of computing power.
As they add more emitters, more environmental factors, more trainee interactions, those demands on the system are just going to keep going up.
And if the system can't keep up,
The simulation will lag, it won't be responsive.
it'll lose that sense of realism.
They're planning to address this through things like code optimization, using cloud computing, looking into specialized hardware.
But it's a tough problem.
It is. They have to find that balance between realism, performance, and cost.
And then there's the whole issue of data.
Right.
I mean, Meta needs huge amounts of data about different types of emitters.
Their characteristics, their
But
behaviors.
getting that data, especially for adversary systems, can be very difficult.
And even when you can find data, you never know for sure if it's accurate or up to date.
It's a big challenge.
They're talking about working with data providers, developing collection strategies, maybe even using advanced modeling techniques to fill in the gaps.
But it's definitely something they're going to have to keep working on.
Data is the lifeblood of any AI system.
So it sounds like there are some real challenges that could impact the feasibility and success of Meta.
There are, but even with those challenges, the potential benefits are significant.
If they can pull it off, it could be a game changer.
It could revolutionize the way the Navy trains its people, plans operations, develops new technology.
It's exciting, but also a little daunting.
Yeah, it's a glimpse into a future where the line between the real and the virtual becomes increasingly blurred.
And it raises some really important questions about how we prepare for the challenges of that future.
Absolutely.
Well, I think we've covered a lot of ground in this deep dive.
We've explored the technology, the potential, the challenges of Meta.
We've talked about the big picture, and we've gotten into the nitty-gritty details.
It's a complex and fascinating project.
It is, and it's a reminder that we're living in a time of incredible technological advancement.
Yeah, things are changing faster than ever before.
And as we navigate this rapidly evolving landscape, I think it's crucial that we approach these new technologies with the sense of both excitement and caution.
We need to embrace the possibilities, but also be mindful of the potential risks and challenges.
And I think this deep dive into Meta has been a great example of how to do that.
It's been a pleasure exploring this with you.
Thank you for joining us on this journey into the world of virtual training and the future of naval operations.
And as always, keep exploring, keep questioning, and keep learning.
I'll see you next time.